Yes, very happy to be here. I'll soon show you why I think basically the most relevant place to be when you want to discuss the global energy landscape is in India. Yes, so just very briefly, we are a company based in Oslo. We have 12 international offices, and every day we do about 1,000 updates to our database, trying to keep ahead of what is happening in the global energy world. So, basically, for you and me in the energy business, basically our task is to make sure that the world gets sustainable, affordable, and reliable energy. Not less than that. And let's see whether this is an easy task. So what's really the challenges ahead of us? First of all, if you look at the sustainability part, the climate part, and partly air pollution, energy, if you look at the climate emission value chain, energy is responsible for 62% of the global climate emissions. As you see here, energy, all the yellow and orange part here is energy. So for example, road transportation is about 10% of the global emissions. In total, we are emitting 55 gigaton of carbon dioxide equivalents, and the global economy is $75 trillion. So basically 55 trillion kilos on $75 trillion, meaning every dollar you spend, you emit about 750 grams of CO2 or equivalent in emissions. So basically, how can we reduce this? And that's partly what I will address, but of course energy is very important. That's about 2/3 of the global emissions. Okay, but if you look at the total consumption of energy, the total consumption is about 13.8 billion tons of energy equivalents. And we expect this to grow by 3,800 tons to 2040. And I will keep the perspective of 2040. If this is approximately 78,000 barrels per day for those that thinks in oil equivalents, but this is the growth. If you look at which nations will contribute to this growth, you see that actually India is number one. And that's why I mentioned that India is a very relevant place to talk about energy. Number 2 is China, number 3 is rest of Asia, then number 4 is Africa, Middle East, rest of Americas, then also global shipping will increase quite much, and Euro-Asia, which is Russia and others, while US, Japan, and Europe will actually contribute on the negative side, meaning that they need less energy in 2040 than today. So let's see what kind of energy we expect this to be. So we split this down into the main energy forms. And realistically, we think that coal is likely to be an important part of the growth in India, as you see, but also we see growth of vehicles, cars, pushing the oil up, also more gas and renewables. While China, as you see, number 2 here, we expect them to reduce significantly the use of coal going forward, while they will grow in oil, but particularly in gas. Then for rest of Asia, still coal will be very important, and then we talk about nations like Indonesia, Pakistan, and Bangladesh also. Africa will have to grow, and then all the 4, but the gas will be the most important thing. And actually in the Middle East, it's very important to export more oil and then to consume more gas internally in the Middle East, so that's why they also have a very strong drive towards more gas. While, for example, in Europe, the bottom here, we see a significant reduction. Almost the ambition is to get rid of almost all the coal that is currently in Europe. This is, however, what the EIA call the new policy scenario. And this is not sufficiently ambitious to actually reduce carbon emissions to the level that we need for the 2-degree scenarios. So still, there are other scenarios that are even much more aggressive, but it's very difficult to actually substantiate those scenarios bottom up to really look at all the investment programs that is required. Okay, then let's then look at consumption per capita, and that is only slightly increasing towards 2040 from 5.1 to 5.3 kilos per day per each one of your consumers. But let's make this more concrete. Let's divide the world into 5 different levels of income and energy consumption. And then, if you look at level 1, and this is about the feeling we have being here today in a very modern and luxury hotel like this, each one of us, are consuming about 15 kilos of oil equivalents per day. We spend about 3 to 4 liters driving our cars. We spend an additional 3 to 4 liters or kilos to make industrial products. We spend 1 to 2 in heating, and then 6 in the old electricity we are using. And then on top of that, some other use. So, but which countries are at the level 1? Because within each country, you find all 5 levels. But each country is also dominated by one of the levels. So if you look at this, we can look at actually the top level is about 1.3 billion people consuming from 88 kilos per day, like in Qatar and Singapore, very high, down to 8 kilos. That's in the Middle East. That's most of the OECD countries. It's Japan and Russia. It's rich countries, it's energy-rich countries, and very warm or very cold countries that have strong economy. They can afford to do this. In level 2, spending about 6 kilos per day, it's 1.8 billion people. This is the people already in China. You know, the middle class in China is a lot of people. Turkey, Thailand, Argentina, South Africa, Italy, Greece, Poland, and Venezuela. And of course, many other countries. In level 3 is 1.1 billion people spending from 5 to 2 kilos per day, on average 3.5. It's countries like Brazil, Mexico, Egypt, Vietnam, Colombia, Ukraine. And then in level 4, that's where we find most of the people in India still. 2.2 billion people that spend between 1 and 2 kilos per day. This is countries like South Asia, as I mentioned, Indonesia and the Philippines. And finally, in the end, it's about 1 billion people spending only half kilo. That's most of the people in the not developed part of Africa, and also some parts of Asia that we have addressed. So what will happen towards 2040 with this population? Well, the green one is indicating people that are actually born within each of these segments. Is 1.7 billion new people. But also we will have a significant migration up all of these levels. From 1.3 billion people will actually migrate from the lower level and up to the next level. And as you see, 1.7 will step up. So all of this is going to drive, of course, increased consumption of energy. As you see, the average consumption for the highest group will actually go down from 14.5 to 12.8 due to energy efficiency. While for all others, we have a migration to the left towards the higher levels that is driving. And then we can start to segment and look at the different segment of countries, because if we want the energy transition, we have to find different solutions in different countries. It's not one size fits all here. You have to look at the nature and the natural given possibilities for each country. We can then still divide the global countries into these 5 levels, the highest level, and then we see that we have some nations that are very focused on gas, like Russia, the Emirates, Iran, Qatar. We have a few countries that are very depending on hydro, that is basically Norway, Canada, and Austria. Then we have the oil nations, which is like Singapore, Kuwait, Saudi Arabia. We have the coal nations like Australia, South Korea, and Kazakhstan, and also the nuclear nations like France and Finland. And finally, the renewables nations, and still you see renewables is very small. We have hardly started on the journey to renewables. And then finally also US and Japan that has a mixed, that is depending on all of this. Then we have also for the level spending less per day that we have seen. Some of them are very depending on coal. some on gas, and India is here, as we have seen, very depending on coal. So let's take a look then on India, because, as I said, you have to have a separate policy for each of these group of countries. When we analyze this bottom up, we find out that there's not one recipe. You have to use all different recipes in terms of technology and in terms of policies. If we look at all the installed facilities in India, we think that you have to increase both the efficiency and the use and utilization of many of the coal plants that is already constructed. You also have to build new one, and this is based on named projects for power generation bottom up. It's quite low on gas, as you see, because you use gas primarily in India for other purposes than producing power. You use it for industrial purposes, producing fertilizers, etc. Also, so gas consumption is not proportional with the consumption. But it should be possible to deliver on this, but this is a huge task, of course. So if you look at the structure of the Indian market, each color is a different owner, and it's actually hundreds of owners. It's a very pluralistic sector, but of course policy matters really. And if you look at the colors of each different power plants in India, you see that still it's very dominated by coal currently. There's some red one, which is the gas, and there's some blue one close to Himalaya, that is the power plants. But still, this is the challenge for India is, of course, to find a balance between incentivizing both the local industry, but also not to do that in a way that you don't delay the development of this. So it's a difficult issue, so I hope we can discuss that further. Also on the road transportation, India will grow a lot. This diagram shows the growth in GDP per capita versus the number of cars. So the mature nations like US and others end up with 5.5 cars per, or 500 cars per 1,000 people. As the wealth is growing. India is hardly started on this journey, and China is already 1/3 to this journey. So we can just expect that the growth and car consumption is going to go up significantly in India and be one of the big drivers of oil in India. Also in terms of the oil sector in India, just one comment on that. Of course, you need local oil and local gas to deliver on the electricity and the oil. We've seen that based on given projects bottom up, we see that this is likely to grow from from 9 to 13 billion dollars invested over the next 3 years. These are based on projects that are already identified, and most of them are blue, meaning this is offshore projects. But then it's some tight oil, very, very limited. But let's look at really the nation that has been the big revolution in oil and gas over the last decade, and that is United States. So if you look at United States consumption of oil and gas, production of oil and gas since 1940s, peaking in the 1970s, and then declining slowly and steadily. But what has happened over the last few years in the United States? Well, the production has already doubled and is likely to double again. So total production of oil and gas and condensates in US could be, in oil equivalents per day, 45 million barrels per day. If you look at the sources for this, the red one here is the shale versus the deep water and the conventional onshore. So shale has really been taking everybody by surprise, and it's now going to have an extreme level of production going forward, and we are quite certain about these numbers. This is based on bottom-up studies of the well curves for all of the well locations in US. We are able to name all these well locations, so we think that this will actually happen. If you look at this by state, we see that Texas, that reached the bottom, is the bottom one here, is going to reach a level of 15 million barrels alone, meaning bigger than Saudi Arabia for Texas alone. And also many other states are contributing, some new states in the north that have never contributing before. So just comparing this total production even with Russia and Saudi Arabia, we see that today in total production of oil and gas, US is already above, and they will be more than twice the size of these other big energy nations globally. Also, if you look at the US consumption, we see that the yellow line is actually the consumption in the US, and it's been a big importer of energy for the last 40 years. Over the next 20 years, they will become a big exporter of energy. And just as we speak, this balancing point is tipping. We are starting to see export of gas from the US, and we see both import and export. So this is changing the global energy landscape. The only reason why it's even not stronger now is that you cannot get the oil out from the Permian Basin, which is the big growth area, because they don't have enough pipelines, they don't have enough truck drivers and trains to bring out oil. So this is the big bottleneck. Here we show how this bottleneck will be de-bottlenecked going forward from about 4.5 million barrels of oil in next year. We think that when you get all these new pipelines mentioned here out, you can double the production from Permian, but there is, as we speak, there are actually infrastructure constraints. So we'll get a big boost of oil into the market in 2020 and 2021 from US that will influence the global energy prices that I'll coming back to when you talk about the affordability. So basically the red part here is the shale oil. This is the part of the global oil production. We think it will peak in the early 2030s, according to also when we think the demand will peak for oil. So this goes hand in hand. And the big shock to the industry is basically that shale will be 25% of the global production. Let's then try to understand how this will influence the global prices and the prices for oil. And to understand oil, we see that this is a very cyclical industry, and then we can study other commodity industries, like we have been doing here. We have been studying the pork industry. Very old slide from 1927, but showing how a commodity industry typically have high prices, they overinvest, overcapacity, and price collapse. People shut down, you get undercapacity, and then prices increase again. That's the law of nature in many commodity industries, and we have made an effort to do the same to understand the oil price, and I will show you some of the results here. So basically, starting with the current oil price, you see here on the left-hand side, this is the oil production, the yellow one, and the gray is oil consumption. And in 2014 and 15, we had a big global oversupply. And 1 million barrel in oversupply per month decreases the oil price with 5%. 2 million with 10%. This history shows that. So basically, we had up to 10% decline of the oil prices in the fall of 2014. And where are the oil prices going now? So I will show you how we can use this system dynamics model to model what will happen with the oil price going forward. And currently, we have a global undersupply of oil, due to that the Iranian oil is going away from the market, the Venezuelan oil is very weak, and also we have disruptions other places. So as you see, we have an undersupply of oil that will drive up the oil price. So we are very kind of bullish from the oil producers' side. Currently, we fear that the oil price could go even higher on the short side. So with this undercapacity, we might see that the oil price will touch 100. However, at this level, you will produce so many infill wells, and finally you get all the oil from the Permian after the pipelines, that you will have a global oversupply in the early 2020s, which, as you have understood now, will result in an oil price collapse. And at this very low level, you will stop infill drilling. And by the way, you will get the effect of the very low oil price from 14, 15, and 16, not starting new offshore projects that has a 6 years lag. So with that, you get the biggest deficit of oil in 2023, 2024, which again will create the biggest hike of oil, and which will create a lot of infill drilling with some lag, and then oversupply and a new collapse, and so on and so on. I think you understand how we can model this, and how actually it's a natural cyclicality in all these markets. However, not to scare you too much, I would say that it's likely to have dampened those two, because this is under assumption that OPEC does not take action. But OPEC is going to take action. So we think that they will produce much more oil as they can over the next year to dampen the price increase, and also that they will cut in 2023 to stop the decline. On top of that, we have a complete deregulation or regulation of the global marine traffic which says that they cannot use heavy fuel, meaning that they have to demand more oil that are in the middle distillate, meaning that it will be a good demand for Brent oil still, which will protect the oil here, while we get too much oil on the very heavy crude, and we get too much propane and too much shale oil. So we get oversupply of each of the ends of the APA scale, while we maybe not get that big oversupply, rather undersupply. So that's why we think that the cycle will be dampened due to these two factors that I mentioned. But overall, this is the cash flow from the industry. This has been the biggest ever for oil companies, more than $330 billion available. All the break-even prices has come down, and basically the oil companies are ready to expand. We expect a lot of sanctioning on new fields coming forward. However, the problem for the oil industry is that they lack people. Because these are the top 450 oil service companies globally, they have lost 500,000 people over the last 3 years. These people we need to recruit back to the industry. So this is one of the reasons why we will have a cost inflation going forward in the oil industry. And we know that this will ripple down to other energy forms. So I cannot promise you really inexpensive oil going forward. And also the currency depreciation is also an additional factor. But the shale will long term still may establish a roof for the oil. It will be 25% of the global consumption, and due to that we will have actually lower energy prices than we would have had if it was not for that. So I think that this is still a blessing for the global consumers of energy. And with that, I look forward to discuss this in other contexts. So thank you very much.